All right, set of notes are a little smaller today because I want to show you the calculator as well as we need it. All right, going into trig functions now. A trig function is just a ratio of any two sides of a triangle. We're going to focus on right triangles for now. So there are your, again, review the blank notes. There's your relationship for all of them. Also recall Pythagorean theorem. You may need Pythagorean theorem at times to evaluate some of this missing stuff. So a squared plus b squared equals c squared. All that's listed at the top. Two special right triangles. You saw special right triangles if you can think back to whenever you took geometry. It's probably already left your head. But that is the 45, 45, 90 triangle and the 30, 60, 90 triangle. So there's your relationship with the side lengths, and we may reference those back if we need them. All right. For right triangle, example 1, for right triangle, triangle ABC with A equal to 5 and C equal to 6, find the missing side length. That should say B, obviously. That was a little oopsies on my part. B, I'll get that fixed on your printed copy, using Pythagorean theorem. So before we find it, let's draw a picture just so, well, we don't need to draw a picture yet. All right, so find the missing side length B. So we know A is 5 and C is 6. So again, we're going with standard right triangle where C is the hypotenuse in this case. So that would be A squared plus B squared equals C squared, standard formula. So if we go ahead and plug in, A was 5 and C was 6. So 5 squared plus B squared. If you don't like B, you could change the letter to like X if you're more comfortable. Equals C, which is 6 squared. So that gives us 25 plus B squared equals 36. We move the 25 over by subtracting. So we get B squared, 36 minus 25 is 11. And then we square root both sides, but because we're talking about side lengths of a triangle, we don't there's no negative. We can't have negative. So that means B is the square root of 11, which does not reduce nor simplify. So we're going to leave it just as is. All right, so then it says find the value of each of the six trig ratios. Give answers with rationalized denominators as necessary. So now I want to draw this triangle. So here's my A, B, not too worried about. So here is just C. So C is going to be, we're going to be talking about, I need an angle, so I'm going to call it that angle. And then we have B is going to be the square root of 11. A is 5. And C is 6. So this is going to be the triangle that I'm referencing. So based on that, there's our triangle. All right, so each of the 6 trig ratios. So those are back up here in your notes if you need to reference them. Just trying to draw it. Well, you know what? B. Okay, let me flip-flop B because I wanted it to match the triangle I drew in your notes. So let's swappy you two. That way it matches that triangle above, just in case you want to reference it. So, all right, so all 6, sine, cosine, tangent, secant, cosecant, and cotangent. All right, so the value of each of the 6 trig ratios, that is a mouthful. So sine of the angle theta, that's why I drew the theta in the picture because there's technically 3 angles there. We want to know which theta we are referring to. So the theta is based on how it's drawn here in that bottom left angle. So sine of theta, if you, again, reference what you need up there, sine is the ratio of the opposite side to the hypotenuse. And remember your hypotenuse, that's the C, that's the one that's opposite that right angle, which is right there. So sine of theta based on this triangle is going to be 5 over 6. Does not reduce or simplify in any way, so we leave it as 5, 6. Cosine of theta. Cosine, if again, look at the definition, is the adjacent leg divided by the hypotenuse. The adjacent leg is the square root of 11. So square root of 11 over the hypotenuse 6. Tangent of theta is the ratio of the opposite leg over the adjacent leg. So opposite leg means opposite the angle, so that is 5. Adjacent leg, square root of 11. So 5 over square root of 11. Now, simplification, rationalize the denominators. It is not considered simplified unless you have rationalized that denominator. So I'll go through the math here, and then I'm going to skip it on the remainder. So So remember, to rationalize the denominator, you multiply the numerator and denominator by that square root. And what that does is it moves it up to the top. So we get 5 root 11 for our numerator. And then the square root of 11 squared is just 11. So rather than, you don't need to show the algebra for rationalizing, move the square root up and drop it on the bottom. So we move the square root of 11 up and we drop the square root symbol on the bottom. All right, the other three, sine. Sine's reciprocal is cosecant, which is abbreviated CSC. So cosecant of theta is going to be the hypotenuse, 6 over the opposite leg. So 6 over 5. Cosine's reciprocal is secant, S-E-C. Secant of theta is the hypotenuse over the adjacent leg. Let me scoochy, trying to line them up. Secant of theta, hypotenuse 6 over the adjacent leg, square root 11. Again, rationalize it, so we should be able to go straight to that. Move it up, drop it on the bottom. So 6 square root 11 over 11. And then tangent's reciprocal is cotangent. Cotangent of theta is the adjacent leg, square root of 11, over the opposite leg, 5. So there's your 6 trig functions. All right, example 2, use the special right triangles shown above example 1, so that's these two up here at the bottom of the previous page, to find each of the following. So tangent of pi thirds. So again, before doing these, it's helpful to know the equivalence of those. So before next two sections, we'll know the equivalent radian. Right now, we're not really comfortable with the radian measures, so I did draw these in terms of degree angles. So here I'll go add on the radian. So 45 degrees in radians is pi over 4. So pi fourths and pi fourths here. So that 90-degree angle would be pi half, but we're not really worried about it. And then for your other special right triangle, 30 is pi 6. And 60 is pi 3. That way we can use the equivalent since some of these are in radians. All right, so tangent of pi third. So if we go look at our pi third angle, 60 degrees. 60 degrees is your pi third angle. So tangent, based on that pi third angle, tangent is the ratio of the opposite leg, which would be this one because we're talking about this angle right here, to the adjacent leg. So square root of 3a divided by a. So tangent is the square root of 3a divided by a. A's divide out, and we are left with the square root of 3. So tangent pi third is the square root of 3. All right, second one, cosecant of pi over 4. All right, cosecant pi fourths, also in radians. Pi fourths is your 45. So cosecant, notice they're the same angle, so it doesn't really matter which one we look at. Let's go with this one here. Cosecant is the reciprocal of sine. The S's and C's pair up together. So reciprocal of sine. Sine is the opposite over the hypotenuse. So cosecant is going to be the hypotenuse over the opposite. So the hypotenuse is the square root of 2. The opposite is a. So we're going to get the square root of 2 over a. We don't know the value of a, so we're just going to leave it as that. Third one, cotangent of 30. So we're talking about a 30-degree angle. So back up here to our triangles. The 30-degree angle is the top one. So we're focused up here now. So for cotangent, cotangent is the adjacent leg over the opposite leg. So the adjacent leg to the 30 is the side length next to the leg next to the 30-degree angle. So square root of 3a over a. A's divide out, and we're left with the square root of 3. Notice, tangent of pi thirds and cotangent of 30, they came out the same. Sine of 45, so 45 degrees, so we're back to the left triangle. Doesn't matter since they're the same. I'm going to go with this one. Sine is the opposite leg, A, over the hypotenuse, square root of 2. So it's somewhere around here. No, further down. There it is. So opposite leg, A, over the hypotenuse, square root of 2. Remember, everything's got to be rationalized. Get comfortable doing it right away. Move it up. So root 2, or I guess we'll say A root 2. Drop it on the bottom, 2. Example 3. Let theta be an acute angle in a right triangle. Use the given information below to find the other 4 trig functions of theta. So it says it's an acute angle in a right triangle. So I'm going to draw a right triangle. Womp, womp, womp. Well, okay, I tried. There we go. That's going to be my right triangle. I'm going to call that theta. Again, obviously that's the right angle. We always want to use that bottom angle to reference theta. So this says sine of theta is 6 over 7. So we were told that sine of theta is equal to the ratio 6 divided by 7. Well, based on the angle theta and sine is defined as the opposite, not odd, opposite leg over the hypotenuse. So based on my angle theta that I've drawn, the opposite leg is the leg opposite that angle, which would be this side. So that side has to be 6. And the hypotenuse is the side, the longest side, opposite the right angle. So our hypotenuse has to be 7. We were also told cosine was the square root of 13 over 7. Cosine is defined as the adjacent leg over the hypotenuse. Well, we already know the hypotenuse was 7. So the adjacent leg, which is going to be the side, the leg next to our angle theta, is going to be square root of 13. So we know it's square root of 13 because we were told, but we could have been not given that information and used Pythagorean theorem instead to find this missing side, which is a little bit easier when it's given. All right, so then it says find the other 4 trig functions. So we've already got sine and cosine, so that means I need tangent of theta. Tangent of theta is the opposite leg divided by the adjacent leg. So the opposite leg is 6. The adjacent leg is the square root of 13. Rationalize it, and you should get comfortable enough to where you don't have to write it initially. You could jump straight to the rationalized form, 6 root 13 over 13. Okay. Then I need secant. The order you find them in doesn't matter. Cosecant. Whatever you want to find next. I usually go to cosecant. I have a set order I like to do them in my brain. Cosecant of theta. Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. Cosecant is hypotenuse 7 over opposite 6. I need secant. That's kind of an ugly secant, but it'll work. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So we're doing hypotenuse 7 over adjacent square root of 13. Or we could have just taken what we were given up there for cosine and reciprocaled it. Again, move it up, drop it on the bottom. And then tangent, we have tangent, cotangents. Cotangent is the reciprocal of tangent, so it does the legs in reversed order. So adjacent leg, square root of 13, over opposite leg, 6. Right. Some identities, we will be using these a lot more in the coming chapter, but I'm going to go ahead and give you some of them so you can work on getting them memorized. Best way to do this is flashcards. Reciprocal identities, that's what we were going over. They're flipped over. So sine and cosecant, cosine and secant, and tangent and cotangent. So just in the identity form. Those are your quotient identities, which tangent is sine over cosine. Cotangent is cosine over sine. Pythagorean identities, I call these PIDs. These are your Pythagorean identities. These are your PIDs. The first one, I call this Papa PID. This is Papa. Sine squared of an angle plus cosine squared of an angle equals 1. Think Pythagorean theorem-ish. That's why they're Pythagorean identities. These other two I call baby PIDs. So 1 plus tangent of theta, tangent squared of theta equals secant squared of theta. And 1 plus cotangent squared of theta equals cosecant squared of theta. The reason I call them baby PIDs is because if you take Papa PID and you go through and divide everything by sine squared, or then go divide everything by cosine squared, you generate these two identities here. So these are your baby PIDs. And as far as distinguishing between the others, we know sine and cosine go together, and then pair your cocos. Cotangent, cosecant. Cocos pair up. Then you also have something called cofunction identities. Cofunction is how to generate certain angles. So sine of theta is equal to cosine of pi half minus theta. So sine and cosine. Secant pairs with cosecant. Tangent pairs with cotangent. So there's all of them just flip-flopped. And just a note, pi halves and 90 are the exact same thing, just depending on the radian versus degree measure. So again, get some flashcards going. You will be needing these in chapter 6 as well. All right, if theta is an acute angle and sine of theta is equals 7 over 8, find the value of cosine theta using the Pythagorean identity. So sine of theta is 7 over 8. It says find the value of cosine using a Pythagorean identity. So we could do it similarly to what we did in the previous example, but because it says use a Pythagorean identity, we have to use a Pythagorean identity. So we want to use the Pythagorean identity that involves sine, which would be Papa PID. So Papa PID is sine squared of theta plus cosine squared of theta equals 1. If sine of theta is 7 over 8, sine squared of theta is 7 over 8 quantity squared. So just kind of a notational issue. This is how I like to write sine squared, but it is equivalent if you like to do the sine of theta and then put the whole chunk in the exponent. It's the same thing. So if sine of theta is 7 over 8, I can plug in 7/8 for sine. And then it's quantity squared, that's sine squared, plus cosine squared of theta equals 1. All right, so 7/8 squared would be 49 over 64. So then we move it over. So we do our 1 minus, here, I'll do the math here for you. I hadn't used it yet, but I need it in a minute. Whoa. Oh no, it's not gonna let me scroll. Oh, there it goes. 1 minus alpha y equals fraction. What did I say? Lost my train of thought. 49 over 64. Enter. 15 over 64. So cosine squared so cosine squared is 15 over 64, so we would square root both sides. So technically, there would be a positive and a negative value. However, for this little moment right here, we're only going to worry about that positive side, and the reason being is because it says an acute angle. So again, if you just think standard triangle lengths, we have to keep this as a positive because it represents a length. So we don't need the negative right now. Now in a little while, that's all going to change when we cover a little more in depth with the angles. But for now, just the positive. So cosine of theta is going to be the square root of that 15 over 64. So remember, square root properties, square root the top and bottom separately. So that's going to be the square root of 15, which is not pretty, nor does it reduce, over the square root of 64, which is 8. example 5. Use an identity to determine the following. Right? So notice it says an identity. It might mean there is more than one way to do it. So it's going to depend on how you see this. So if I'm looking at this tangent of 13 degrees times cotangent of 13 degrees, I would use a reciprocal identity here. So I know that cotangent of 13 degrees using a reciprocal identity is 1 over tangent of 13. Well, tangent times 1 over tangent, those tangents would divide out. That's 1. So the answer is 1. For B, cosecant squared minus cotangent squared. Anytime you see squared, that's a red flag. That is one of your Pythagorean identities. And on those identities, they can be algebraically manipulated in any way you'd like to. So if I come back up here to my pits, I know that cosecant squared is 1 plus cotangent squared. So cosecant squared of pi sevenths is, I'm going to use baby pid, 1 plus cotangent squared of the same angle, pi sevenths. And then I just carry down the rest of the problem. Oh, come on, zoom. Cotangent squared minus itself, that's 0. The answer is also 1. So it's just to show you that you can manipulate those identities in any way you like to simplify a problem. All right, example 6. Cofunction identity to give an equivalent value. So notice in certain cases they are using names of identities, so make sure you know which ones are which. So cofunctions, sine is cosine, and so forth. So it says sine of 46 equals, well, sine's cofunction is cosine. So what we're wanting to use is that sine of theta is cosine of, and then it's either 90 minus theta or pi half minus theta, depending on radians or degrees. Because the 46 is given in degrees, we want to stay in degrees. So sine of 46 is going to be cosine of 90 minus 46, which is 44. So an equivalent expression would be cosine of 44 degrees. If I type both of those in, I get the exact same answer. Secant of pi sevenths, secant pairs with cosecant. So it's going to be cosecant of pi halves, since we're in radians, minus pi sevenths. And again, to do your little fraction math here, you can just eliminate the pi's and you just want to do 1 over 2 if you need the little help with your fraction math, speed it up, minus your 1 over 7. And we get 5 pi 14ths. So cosecant of 5 pi 14ths. So again, if we did both of those, we would get the exact same answer. All right, so this is where I really had the calculator first. I don't need that. We're going to clear it off. All right, example 7. Find the value of each using a calculator. Round your answer to 3 decimal places. So the most important thing you want to understand about trig functions is the unit of the angle matters. You will get different answers depending on whether it's in degrees and radians. You must change your mode depending on whether you're in degrees or radians. Default calculator, so if I hit the mode button right next to second, notice it's in radians. So what I'm going to do, I am going to type in, the first one we're asked to find is sine of 35. I'm going to hit sine 35. And that's what it's going to spit out. And I'm going to tell you right now, that is wrong. When I type this in right now, it is reading that 35 as a radian angle measure. Our problem here clearly has a degree symbol. Make sure you change your mode. So I'm going to hit my mode button. I'm going to go down to that row where it says radians over to degrees. Notice the blackout switches over to degrees. And I'm going to type that in again. I get a totally different answer. So if you are not careful with the mode of your calculator, you will get these wrong if you forget to switch back and forth. 5, 7, 2, 3, it would be 4. So 0.574. Secant pi sevenths, notice you do not see a secant button on the calculator. I see a sine, cosine, and a tangent. Those ones in blue, that sine -1, that is not a reciprocal. That is a whole nother trig function we will learn about later. So instead, what we want to use here is we want to use a reciprocal identity. Secant's reciprocal is cosine. So we want to do 1 over cosine of pi sevenths. So I've got to switch modes because I'm in radians now. So I'm going to go back to radians. And I'm going to do a fraction template because I like it. 1 over, and then I can hit my cosine button. Type it in a fraction if you want. Pi over 7. Oopsies, hold on. Not a 9. This calculator's a little tiny. Delete. 1 over. There we go. No 9. Which is 1.1. 0.99 is going to bump it to 1, 0. Cotangent 75. Again, we don't have a cotangent button, but we have its reciprocal, tangent. So 1 over tangent of 75. Once again, mode button. Don't forget to change, and it's annoying. You are going to have to change back and forth. So alpha y equals 1 down tangent 75, close parentheses, 0.268. Oh, no more. Cosecant 2 pi fifths. Cosecant's reciprocal is sine. So that is equivalent to 1 over sine of 2 pi fifths. Mode first, because I think I'm in degrees. Yep, of course I am. Yes, I'm making you go back and forth so you practice it. Alpha y equals, for my fraction, 1 over sine. Alpha y equals again for another fraction, 2. Then my pi button, and then my 5 on the bottom, out and close, and voila. 1.051. All right, example 8. Find the value of each angle theta using a calculator. Round your answer to 3 decimal places. So this is where those other little buttons in blue, the sine -1, cosine and or tangent -1 are going to come in. So those are called inverse. So that's kind of like multiplying by a reciprocal. It undoes something. And so if I want to undo sine, I use its inverse operation, inverse sine. To undo multiplication, we use the inverse operation division. To undo addition, we use the inverse operation subtraction. So to undo a sine, we use what's called inverse sine. Inverse sine is that sine -1. So I am going to take the inverse sine of the left side. Well, if I did it on the left, I got to do it on the right. So I'm going to take inverse sine of that right side, which is 0.145. Let me see, what are we doing? Oh, I didn't tell you what units. Let's go with degrees. Yeah, again, be careful. If it says theta in radians, make sure you change to radian mode. So let me make sure. Nope, of course I've got to go back. I'm going to go into degrees. So we're going to do these in degrees. So the inverse sine undoes the sine, so that gives us theta by itself. So I just need to type in inverse sine of 0.145 into my calculator. So second sine 0.145. Oh. Yes, it's a free calculator. The ads are getting on my nerves. Enter. So we get the degree angle 8.337 degrees. If you're in degrees, make sure you got a degree symbol on there. If you're in radians, you don't need anything. I wrote that way too big. Scoochie. There we go. All right, B, tangent. So to undo tangent, we use inverse tangent. So I'm going to inverse tangent the left. Well, if I did it on the left, I got to do it on the right. So I'm going to do inverse tangent, the 0.516. And again, we're just gonna stay in degrees. If it says theta in radians, make sure you go change your mode. So second tangent, 0.516, close, enter. Theta is 27.294 degrees. All right, example 9, use the given information to find the missing sides, notice it's plural, of the triangle. Give your answer rounded to 3 decimal places. So then it says, recall, capital letters represent angle measures, lowercase letters represent the side lengths for the opposite angle. So note if the angles are in degrees versus radians. So I'm gonna get my triangle drawn. Where you put the ABC's not super important when it's not given. So I'm gonna go, let's go A, B, C. That works. Just note where your right angle is. All right, so it says capital letters represent angle measures. So A is 61 degrees. So I'm gonna put my 61 degrees right here. B, little b, that is the side length, is 10. The side B is opposite angle B, so that means that side goes here. So based on my drawing, this would be side little a, and then this would be side little c. All right, that's all I got. I don't have enough for Pythagorean theorem. I'm missing too much, so we're gonna have to use inverse trig. So first one I need to use a trig function that uses the 10 to find either A or C. So 10 is the adjacent leg to the 61 degree angle. So I would be looking for adjacent and hypotenuse. The trig function that uses adjacent leg and hypotenuse is cosine. So cosine of A is going to be equal to the adjacent leg, which is B, divided by the hypotenuse, which I've called C. And if I plug in what I know, that means cosine of 61 degrees is equal to 10, because that's B, over C. So then we just algebraically manipulate this equation to get C by itself. So if I multiply both sides by C, I get C times the cosine of 61 degrees equals 10. Divide by the cosine of 61. So C is 10 over the cosine of 61 degrees. So we need to make sure we're in degree mode. So I'm gonna hit my mode button. I am. All right, alpha y equals 10 divided by cosine 61, close. So C is 20.627. The line here. All right, now I want to go find A because we're missing A. So B, based on knowing the angle A, B is the adjacent leg, A is the opposite leg. So the trig functions that use the two legs are tangent and cotangent. Because I don't have a cotangent button on the calculator, I would choose to use tangent just so you don't have to mess with converting it into tangent form anyways. So tangent of angle A is equal to the opposite leg, which is little a, divided by the adjacent leg, which is little b. And then we go plug in. So tangent of 61 degrees is equal to A, because we don't know it, over B, which is 10. So multiply both sides by 10. So side A is equal to 10 times the tangent of that 61 degree angle. So back to our handy dandy calculator. 10 times tangent 61 close is 18.040. 18.040. And these are side links, so make sure you don't get angle measures. Don't get a degree symbol on there. All right, done. All right, applications of trig. So now we're going to do the same thing we just did in example 9, but we're going to have to reference it to some information to get a triangle drawn. Sometimes the drawing will be given, sometimes it will not. So 2 quick reviews: angle of elevation versus angle of depression. An angle of elevation goes out a horizontal. So here's my horizontal. Come on, auto line. and then it goes up. So like if I go out that horizontal and then up, that is an angle of elevation. Scooch it up a little bit. If I go out a horizontal and down, that is an angle of depression. So up, elevation, down, depression. D for D. All right, example 10. See if I can get all the words in there. To find the distance across a lake, a surveyor took measurements 630 yards away. The angle of elevation to the other side of the lake was 40 degrees. How far across the lake? How far is it across the lake? Rounded to the nearest yard. Okay. All right. I don't know what's going on, but that's going to be my little blob of a lake. All right. Pictures are important. He took 2 measurements. I don't know where he was, but I'm just going to put him there. Those 2 measurements were 630 yards away. So I'm going to call that point A, and I'm going to call that point B. And they are 630 yards apart. The angle of elevation to the other side of the lake was 40 degrees. So the angle of elevation from A or B, it doesn't say, so it does not matter. So angle of elevation out and up, it was 40. So that angle right there is 40 degrees. How far is it across the lake? So again, autocorrect here doesn't do a very good job for my right angle, but right there, that's going to give us the length across our lake. If I could draw it a little bit better. So like if I could scoochie that out some. Yeah, here, we'll draw our lake just a little prettier. I think I was supposed to have an image on here and I just forgot it. That kind of makes more sense. There we go. All right. So how far is it across the lake? Well, across the lake would be this side here, which I'm going to call it X. You could call it little a if you wanted to. I like to use X in most cases. What you call it doesn't matter. All right, so based on my drawing, I have an angle. Based on that angle, I have the adjacent leg, and I am looking for the opposite leg. So opposite and adjacent, I'm going to use tangent. So tangent of 40 is equal to the opposite, which is leg X, divided by the adjacent, which is 630. So if we multiply by 630 on both sides, we're going to get 630 times the tangent of 40 degrees. Make sure you're in degree mode, which I believe we still are mode. Yes. So we're going to do 630 times the tangent of 40, and that is 528.63, rounded to the nearest yard. So I'm just going to write this down. 528.632. This is what I tend to do with word problems. ... That lets me know this number keeps going. And then I'll go read to make sure I answer correctly. To the nearest yard, 0.6 would be 529 yards to make sure I answer it right. So again, elevation versus depression, be mindful of which is which. If the picture is not given, draw a picture. It makes them a lot easier. And I can't remind you enough, watch your mode in your calculator. All right, go get your homework done and let me know if you have any questions.